DisruptOps helps you find and fix cloud security issues fast. Getting bombarded with irrelevant alerts is frustrating. DisruptOps gives security and DevOps teams prioritized findings and routes relevant alerts to Slack or Microsoft Teams with automated response options that save you time. Finally, security is inside your workflow instead of in your way. Listeners can access the full platform free for 30 days by visiting securityweekly.com/DisruptOps. When it comes to web app and API security, the choice is simple. You can choose Fastly's security solution that teams will actually use in full blocking mode, just like 90% of their customers. Or you can stick with costly options that you probably just turn off. You can get Fastly's all-in-one platform that protects apps everywhere they live, however they're built. Or departments can agree to disagree. You can go to securityweekly.com/Fastly to learn more. Or you can just wish you had. Looking to improve your web application security? Probly is reinventing web application security. Probly focuses on the vulnerabilities that matter, eliminates false positives with evidence-based scanning, and provides a simple point-and-shoot solution that is easy to use. Probly's thorough coverage ensures accurate identification of vulnerabilities in any modern web application or API. Improve your web application security processes by visiting securityweekly.com/Probly and start your free trial today.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by John Kinsella. Security Weekly is more than happy to announce that we will be at InfoSec World 2021 in person this October 25th through 27th. This year, our annual partnership with InfoSec World is extra special, as we are both business units under the Cyber Risk Alliance brand. So, what does that mean for Security Weekly listeners and InfoSec World attendees? You will get to see and hear from many of the Security Weekly team at the event, and you will save 20% off your World Pass. Visit securityweekly.com/ISW2021 to register using our discount code. Security Weekly is also ecstatic to announce that Security Weekly Unlocked will be held in person this December 5th through 8th at the Hilton Lake Buena Vista. Call for presentations and early registration for Security Weekly listeners is open now. Visit securityweekly.com/unlocked to submit your presentation and to register for the early registration price before it expires. And this brings us, Mr. Kinsella, to the news of the week. So I know you've got something that was standing out, and this is ongoing work from Google. They've been doing quite a bit of work the last couple of months, at least in blog posts, about supply chain. And supply chain, of course, is going to be the center square of the bingo card throughout 2021. So I think it's unavoidable, unfortunately, but there's at least something maybe new we can talk about this week from SLSA. So give us a couple steps. How do we step into SLSA here?
Okay, I should have seen that coming. How do we want to go into this? I think you said it pretty well. Google's come out with this thing called SLSA, SLSA for those trying to Google it. It's an end-to-end, and to read directly off their title, I'm going to be lazy here. End-to-end frameworks for supply chain integrity. I like the way you phrase it. The center square on the bingo card is definitely what it's appearing to be this year. So this is interesting. I linked to the blog in the show notes. I'm sort of in a temporary environment here right now, so I'm on my phone looking at this stuff. The first thing that really caught my visual self, there's a diagram in here where they sort of break down between source integrity, build integrity, and they actually do a pretty good job of actually showing a decent list of places where a threat actor could actually try and get in and modify the supply chain. So I think for those who need a visual reference, it's a pretty decent one. Good number of examples, including actually saying, hey, referencing Codecov, we're going to talk about that in a few minutes, referencing attack on package mirrors, SolarWinds, we got to remember them, PHP, Linux hypocrite attacks. So that was the commits from our researchers before Christmas, I think. So they have a bunch of good examples, and then how this framework would have mitigated those. But I don't know, and maybe I haven't read enough into this yet. I'd love to see more meat behind it. It seems like it's just sort of a framework, and I feel like we've got a few of those already this year. So I've said this in different circles over the last few months. I think one of the problems we have as an industry right now, before it used to be all the vendors are all trying to come up with the same product, and Adrian's got a great talk on that. But now it's like a lot of these, I'm going to call this open source for right now to fit into this argument. But a lot of the different open source or standards bodies are all sort of coming up with the same standards. So, you know, CNCF has some stuff around this. These guys do. I think Cloud Security does. I know MITRE's working on something. So there's all these different groups that are working on the same thing. So then it's like, which one do you want to pick from? And, you know, that brings you back to the joke on standards. But it is an interesting read if for folks who are trying to get their head around what do we do around supply chain. It's a good place to start. I just wish some of these guys would actually work together instead of coming up with the same thing all over again.
Yeah, I think in the spirit of in the joke on standards, on the joke on commentary as well, trying to struggle to add to something that you didn't already cover. I think the thing that I'll try to squeeze in here too is that it at least is nice how the graph as well stood out to me, that it pulls out a threat model and it's highlighting the two major aspects of here's an artifact, meaning here's the thing we've built and we've got a SHA-1 hash or it's been signed or something like that, so we can just prove that the integrity was maintained from code to commit to deploy. But there's also the process that it's focusing on too, and hopefully that process is something that I know we're talking about frameworks and, you know, we need to do things, and it's not so prescriptive quite at the moment, but the process should be remembered. So because those are, as the threat model shows, those are some attack vectors into modifying the source or making sure that the integrity of the artifact that you've built hasn't been subverted in some way because of some problem within the build infrastructure as well. But to your point, the Linux Foundation has been writing a lot of things about SCIM, SCIM, SBOM. There's also the SDDF, I think. I'm trying to pull out as many of the acronym, SSDF, Secure Software Development Framework. This is also from NIST. You know, all of these frameworks that are basically saying a lot of very similar things. Have people review code, make sure that the code that is, you know, the SHA-1 hash of the repo matches what was built and matches what's get deployed, and then as your users, provide a way for your users to verify that this is the artifact you built. Sort of that end-to-end process. And I think we need less perhaps of just reminders of that's what we should be doing, and more tooling to help us be able to more easily say, here is the certificate transparency, if you will, of the world to show the binary transparency or binary integrity of the dependencies or of all the open source libraries that are being consumed by different projects.
Yep.
I think then you set up a pretty good segue. Let's talk about Codecov, because I brought in this article briefly just as a callback to Codecov. We talked about a breach and supply chain, of course. And as a quick reminder, this was a compromise in their bash uploader script where the binary that the bash uploader was pulling from was modified by the attacker. So this is a classic pipe a bash script through curl, and as long as the HTTPS certificate works, then basically curl's going to execute through that bash, install your binary, and you're good to go. Install either the malware crypto miner or legitimate binary of your choice, depending on what day of the week it is. What was interesting, stood out to me, was they wrote up a nice, bit of more of a postmortem, and they're also describing how and why they're switching from Bash, and in this case to an NPM, a Node.js implementation. So it's also a little bit of tie to that idea of refactoring and re-architecting that we touched on a little bit last episode as well. But I'm curious, John, if you had the choice to rebuild from Bash into another mechanism to handle this uploader, you're laughing. I don't know why you think you know what the question I'm going to ask is, but it's going to be, would you have used Node.js?
I'm glad that we think along the same wavelengths. That sort of caught my attention in this article. And so it's let's think about it from an engineering organization point of view. If you've got a team that knows Node, it's going to look better than Bash, right? the second thing that really made me snap the neck in there was a node binary. I didn't know those existed, but hey, that's sort of cool. No, man. What would I pick for this? I mean, it's such a simple thing, right? That I was just starting to look at the node code before this, and I didn't look at how many. I wanted to see how many imports they were doing, like how actual, talk about supply chain. How complex was this thing going to be? Because that's the problem we see with Node, right? It's not the JavaScript code yourself you're writing. It's all the stuff you bring in and all the friends and enemies that you bring along with you. So maybe it's okay. It wouldn't be my first choice. What would be my first choice? I mean, I'm a Go guy nowadays. Looking for excuses to use Rust still. Maybe even, Python. I think there's lots of choices. It depends on how complex the beast is. And the problem is not just how complex it is, but how complex it's going to become as they start adding functionality over the next, year or three. Do we need to add a coffee maker in there? And then which node libraries do we need and how many vulnerabilities do they have? So I think that's where my concern was. But yeah, that was the first thing that popped into my head.
Yeah, and I think what's the quote from Jamie Zawinski? Every software is going to expand until it supports email. So maybe the uploader will support that. But no, I think I did like their thought process. So they were clear about their thought process of the benefits of a new uploader. So they're saying that they wanted to have a compiled binary, so it makes it just more difficult to muck about with. They wanted to have it something that's more understandable, maintainable. So they were talking about that. So now, of course, we can have different discussions on what is maintainable versus Node versus other choices. But if this is what your development team knows, probably smarter to go into that rather than the magic of syntax and what that looks like within Bash scripts. So kudos to them for changing, responding, and moving things forward. So that will be just kind of an interesting. I suppose that's one example of the framework in practice. This software supply chain framework in practice of having deliberative engineering choices into how do we obtain updates and maintain that software throughout. I'm going to use this since you also mentioned Python. You're setting me up with all the great segues today. Thank you, John. I had another kind of semi-obscure, perhaps, article just talking about using the abstract syntax tree, using the AST, not to crawl it, as we were talking last episode with things like semgrep, but actually using the AST to modify a software, sort of a dynamic patching or live patching, if you will. And I thought this was a really neat reminder of why the ASTs are really neat and can be pretty powerful tool beyond just having a semgrep type of style to walk through and have good semantic understanding of, is this a variable name? Was this just a code comment? Is this a secret? Is this a variable that I care about and want to respond to, et cetera, et cetera? And in this case, just saying, we have perhaps a known vulnerability, or we have a code smell or an anti-pattern that's pretty easy to identify. And rather than assign an intern for the next 2 months to go and remove and replace all of the instances of this particular code smell, we could do this programmatically with a degree of confidence. And this was just kind of a neat approach that I wanted to highlight and throw that out there for in this case for those of you approaching Python.
I think I'll talk about the positives first. So that's the
oh, there are minefields here. Yes.
Yeah, that's the. I mean, I'm having flashbacks of having done that in the past. If you have, like, say, I don't know, 20, 30,000 lines of code and you need to do some sort of refactoring on it, that will give you flashbacks. So from that point of view, going through trouble, it's funny, right? It's the how big of a problem does it have to be before you stop doing it manually and actually go and figure out how to use a Python script like this. The example that comes to mind to me is, like, if you're doing search and replace in VI on a large file, how long until you go back in Google, okay, how do I do search and replace in VI again? But so yeah, that was interesting. The part that sort of scared me a little bit was they commented about they were doing this on, I think it was like 4 or 5 nodes that they were replacing 150,000 lines of code or modifying a pretty decent amount of code on. It didn't sound like a Git repo was involved in that. And I'm like, what, are you doing this live? So that's the part that I thought was a little weird. And maybe that's just how I'm reading the article.
Yeah, I think there's the aspects are definitely you're going into this with confidence that you have good testing, because the next best
Yeah.
way to fuzz your software is to just change your software programmatically, or automatically in this case, and see what happens. So it's not quite a YOLO deploy; it's a YOLO patching, perhaps. But I think still a good tool to consider, but it's probably not going to be the thing that you're going to approach unless you have a pretty mature software development process and some high confidence in your testing. But still really fun things to do with ASTs. And the reason I was thinking of that is that once again, we have come across some printf family of bugs. We were shaking our heads also last episode. So for those of you who haven't caught the last episode, go give a listen, then come back. But we were talking about how just how dead simple some sprintf bugs were in actually, speaking of Python, building some command lines or to be passed on to Python that were simple string concatenation. Here is a funny and quirky iOS bug that highlighted that format string vulnerabilities still exist. So format strings are, for those of you who are unfamiliar, that's basically the printf family of functions have %s, %p. You can pass these percent prefixed flags to be alliterative into the function parameters, and that will influence the data types that you can populate, or how they're formatted in terms of integers or decimal points, etc. And they were all of the hotness around the early 2000s, and then they did kind of disappear. And I want to say they disappeared because there's a lot of effort into expunging them from all of the vulnerable C code, and a lot of compilers and libraries did some tweaking to make those, that class of family more difficult to create as well as to exploit. But lo and behold, here was someone who created a nice and funky Wi-Fi name, connected their iPhone to it, and bad things happened. So good on you for finding a format string. Long may they live.
Yeah. And we saw this about the same time last week. You got it in before me. You did a much better job in intro than I would have done. But I'm sort of stumbling for words like how did this exist? How did this even come around? Right? It's and not so much that's bad, but how did this dude find this? I mean, for folks who haven't seen, it's what I think it's like 4 percentage characters, so %p, %d, %s, %t as an example. You make that your Wi-Fi name, and you join that with your phone, and suddenly your phone stops working on Wi-Fi. It's like, I'll censor myself, but how? What the hell is going on there? And then also, how did this dude find us? So there must be some other sort of sniff going on that these guys realize that there's something going on. I think his quote in the article was, or their quote was, he didn't specify how he found this, but obviously he was up to some sort of hijinks, right? But yeah, it's that's an interesting one. I suspect people are a certain group of the population have realized that there might be something more interesting there, and they're probably crazily trying to fuzz that now as we speak.
No, absolutely. So yeah, I will be curious if this does engender a resurgence in looking and discovering, unfortunately, many more format string bugs, and throwing in those %ps and %ns in particular, because if you just look at the man page for printf, there's already the warning that, and I'm going to mostly quote here, that programmers are strongly advised never to pass untrusted strings as the format argument. Which not too surprising there, because an attacker can put format specifiers in the string to mangle your stack. And that's actually exactly what this %n can do as well. And that's the %n, you noted it, John. That was one of the final character here in this particular Wi-Fi. network name, but it's an interesting combination because not only do we have a function that can format a buffer to be written out to screen, but it also can write the number of bytes already printed, pop that onto your stack. So there was always an interesting way of how this type of function is a bit weird and can work in very surprising ways, because it's going to actually write back onto your stack and potentially with user or attacker influenced data. So it also threw in a PDF that gives a great history, I think, of format string attacks from 2005, if I'm remembering correctly. So encourage listeners who are interested about that and want to go start looking for this, go give that a read and start throwing in your %Ps, %Ss, and %Ns into all of the interesting inputs and see what starts to fall apart. Maybe go find some more and find yourself some bounties. Speaking of bounties and also GraphQL, so we had a little bit of foreshadowing, John, from the last segment when you mentioned GraphQL. There was a article here about from a $30,000 bounty for basically what the researcher wrote up as a 4-step process to bypass basically an authorization problem within the API. And it's, again, in that category of dead simple type of attack, not to take away from how impactful it was, but just kind of showing the aspect of it can still be really hard to really easy to mess up authorization and misapply it, because this attack didn't rely on any garbage input. It didn't rely on anything that a input validation would have found. It really just relied on, oops, we forgot to apply an authorization check here, and someone found it because they were patient and diligent and demonstrated how to exploit it. One quick caveat, you do need to get a media ID, so there is a little bit of a prerequisite here, but I think clearly Facebook, Instagram were saying, nah, that's not enough of a prerequisite to say this isn't a problem, so here's $30,000. Go invest in becoming a security influencer now, perhaps.
Get that TikTok going. So I think, yeah, and that ID, to be clear on it, is you have to brute force that, is the sense I got from it, right? So this, one of the problems I have, I'm not a huge fan of GraphQL. It's okay, it's nice. I understand the use from a developer's point of view of, well, we can just provide an API and then, the front end guys can go and write their queries as they need to, and we'll never have to touch it again. But there's, from what I've seen, I've used GraphQL probably twice over the last 18 months now, are built into programs. I've never had a really, really solid feeling of the libraries I was using, partially because their documentation was sort of weak, and I'm talking about the big ones, and I think one of them actually comes from Facebook, if I remember right. There's this sense of you're doing something which is powerful, but I never really felt like I had a really strong grasp of them, and I think the result of that is partially something like this, right? I'm not saying that GraphQL causes authorization issues. That's obviously not the case. But potentially people, and I would expect a company like Facebook to have very solid understanding of what they're using and what they're putting out there. I'm doing really good today at filtering myself and or censoring my swear words. But I don't know. I suspect that has something to do with it. I think there's a lot of complexity which is introduced with GraphQL. And while it can be used for a lot of great things, KISS is around for a reason. So that's I'd be very leery of bringing this into an application unless the team really understood what was going on with it.
Yeah, and I think to me, there's that aspect of abstractions can be good, but a little, if we've gotten too much of an abstraction, or if we've gone, if we've obscured a lot of the areas, if we've obscured security boundaries, that's the part where this abstraction can potentially bring in vulnerabilities, mistakes. And that's where I think it's something like GraphQL. Just use it as the example. It's not the cause here. But that we can say, here's one database has controls on its data in one method. Here's another data store that had controls and was expecting an identifier from something else in order to control access to it. And I'm starting to get a bit hand wavy here on my terms, but I think the point. Yeah, go ahead. Pull me out here.
And either Nuno or Thiago, I can't remember which one, but on our previous segment, when I was picking their brain around GraphQL scanning, they mentioned something very interesting, and it slipped off my mind at first, is that abstraction layer that you're bringing in with GraphQL. Depending on which vendor solution you're using out there, you might be obscuring away more than one database. So the end solution looks really nice and really clean, but if you just sort of take one of the vendor implementations, say, hey, I want to use these two databases, and this is my route, that could get interesting, not in a good way. So yeah, it's a lot of potential with it. It's a very powerful thing, but as we say a lot, the power brings potential badness.
Potential badness. There is also, so we're going to shift from abstractions to ancientness, and I'm going to coin a new word there. Here is another article about systemd, and this was a privilege escalation problem in it. Two things that stood out for me. One was that it was actually some newer versions of the distro that had picked up the insecure code and put it in there. So it was a little bit of a surprise just in sense of figuring out, am I vulnerable or not? And the other aspect was, here is a 7-year-old bug that has finally been publicly disclosed and is getting patched. And we've seen, 7 years, 10 years, I think up to 20 years just this year we've been talking about, or maybe it was 2020, about the email from the work from Qualys that they were highlighting on some 20-year-old bugs. But one of the things where my mind went there was, is this a good or bad sign? Or, glass half full, half empty, in the sense we're finding these ancient bugs now? Are there more lurking out there? Or maybe what's the techniques that we have that are getting better, that we're finding these bugs and squashing them? And I don't know what the answer is here, but I have some ideas. So I don't know if if John, you want to dive into maybe that age aspect of this, or there was a different part of it that was standing out to you.
You mentioned having ideas. I'm like, oh, let's hear them. Let's see. The age thing was interesting. I mean, okay, yeah, great. What's interesting about it actually is that no one's found this one before. So I think a lot of us in the Linux world, we've always sort of, since systemd has been around, we've been like trying to keep that thing a little bit at distance from us and not digging as much as we probably should have to really understand it inside out. And the result of that is we now found out that they're using something other than sudo to do privilege escalation purposely to launch programs, which, okay, that's cool, but I bet you someone out there knew this. This feels like something that somebody has known and been exploiting for a while, and it's just now becoming public. That's my sense on this one.
Yeah, I'd be very curious about that. And it was also the introduction to me about trying to dive into Polkit and read about the policies. And again, there's a lot of flexibility that these types of configuration mechanisms can introduce, but it's also pretty easy to make mistakes. And yeah, I think that was just more of, it's seeing these long-lived vulns does beg the question of who else knew about them, how often have they been abused. And I guess I suppose the other thing on the top of my mind is that I'll be curious to watch maybe throughout the rest of 2021, 2022, do we see sort of this spike in long-lived vulns that are being identified through fuzzing, through code reviews, through something. And as the world is shifting to better designs, different languages, we're going to see fewer memory safety issues, or like in this case, fewer just obvious issues, unfortunately, in after the fact, once this particular type of vulnerability is pointed out and how simple it is to exploit. So again, this is the conjecture episode. Yeah. What do you wonder about, John?
I wonder about lots of things. I wonder if some of these vulns we've seen, and in the Qualys case, obviously that's professional curiosity, but in some of these other ones we've seen like this, I wonder if this is a result of people being locked up for the last year and just starting to poke around a little more than they would have otherwise. You think maybe?
There we go. That's a great idea. I would be very curious as how many people have actually spent more time reading with code, playing with code, and so on. So it will also be nice to see, because Google has been also pushing on open source, and we're just talking about SLSA. They've been pushing. They have a open source fuzzing project that they've been running for a while. Maybe we'll also start to see the projects that they pull into that umbrella become larger. And I can't remember. I have to go back and double check on what we talked about around the open source bug bounty. There was a discussion of a bug bounty as last resort that was also just kind of a thought exercise. What would it cost to say, let's just have a bug bounty for open source, as well as I know there's Linux Foundation, I believe, has a bounty program for open source. So maybe there's some money to be made. Not $30,000. These volunteer and projects don't quite have the deep pockets that someone like Facebook has. But hopefully there's something out there to highlight more of this type of bug checking, bug bounty looking. I do have one final article that I wanted to pull in here, and it's a bit more. I didn't want to get into navel gazing necessarily, and to a degree, we use the phrase shift left just to mean early on in the SDLC, or we use the term DevOps to say shifting responsibility for developers on to take on more responsibility for security and kind of what that entails. And I don't think we really need to get into strict definitions of what shift left means or DevOps versus DevSecOps, because honestly, developers don't care. They're busy writing features, releasing code, and making it secure. But this article was highlighting, I think, a good point. It was pointing out why shift left security has become a bit of a misnomer. I would say maybe not as so much a misnomer as just we need a reminder that there's a lot of software that is running that still needs to have some observability in it, still needs to have some type of security process around it, some security tooling that's monitoring it for either known vulnerabilities as they get disclosed, or have a way to identify vulnerabilities. So I think the point that I would make in response to this article is not so much put all of your eggs in one basket and everything is easier and better because you're doing all of your security checking at the development side of things as you're writing the code. But remember that for as much effort as you're putting into the securing the writing the code, there's still some deployed code monitoring that you still wanted to check on. So I think that was the not necessarily succinct way I put it, but that was what I took from this article. And we
still
can
try
maybe,
to parse my thoughts.
Yeah,
still try to parse my thoughts on this one. Sorry,
you've been restraining yourself quite well. Unleash now. Let's hear it, John.
No. This is a sponsor.
Okay.
I think, he has some interesting points. I think what I would say is we have to remember that we're in our little bubble, right? So we've got a pretty good number of listeners and viewers on Application Security Weekly, right? We're proud and happy to be here, and I love you all listening to our stuff, but we're still a pretty small fraction of the software development or security development or any of those worlds out there. So I think if you get outside our little bubble, shift left is still quite a thing. And I think it's I always talk about, I don't want to preach the security crowd. I want us to go out and preach the rest of the world. So I think what's going on here is a little bit the reverse of that. It's preaching inwards instead of preaching outwards. And I think that's where we get into a little bit of not so much nasal gazing, but we're sort of, it's the same thing as like the cloud doesn't exist, it's just someone else's computer.
Sure.
Again, I'm going to censor myself in my response, but it's that type of thing. It's like, okay, dude, fine, give it another name. It's the concept of the phrase I've started using recently, you probably heard on the show, is developer first, right? So I want my security tools to really be focused around something that developer can use if that's the end market, not just take a security tool and give it to the developer, right? Don't just give them a scanner, but give them a scanner that actually works in their environment, speaks in language they know. The results are understandable. All those things that it's designed for being used by the developer, not by the security person. So I think that's where shift left comes interesting to me, not just the tools themselves. It's like saying that there's a DevSecOps tool. No, it shouldn't be DevSecOps. DevSecOps is a concept. So that's it's interesting, but at the same time, not too much of the navel gazing.
Yeah, no, I think putting developer first is a great reason to give you the last word for this episode. So I think that was a great way to end on. So I want to thank you, John, for joining us. Thank all of the listeners. We're going to see you again next week on Application Security Weekly.